Good morning, buenos dias, доброго ранку, слава Україні. Хиваюта. Now it's 4 languages. Good morning, everyone. Let me know if the audio is fine. Also, let me know where you're from while we are just starting the stream. Always curious where we're coming from. I mean, where my viewers are coming from. And let's get started. So once I'm done with the audio check, I don't know if anybody watches the GeoGuessr channel. He always checks if he's recording now. He's really recording now. And I gotta check if the audio is fine. Good morning. Thank you. Fine, let's get started. So, I actually wanted to make streams more rare and create more short videos, but then they started to threaten us with the nukes. And yesterday again nukes, and I thought maybe every stream could be our last, so I should take the chance. So a couple of days ago, the client contacted me to create something, and although it seemed rather simple, but then I wasn't able to find the actual code. So let's switch the screen and let's dig into it. Good morning, everyone. Switch the screens. Right, so this is about this kind of simple lava lamp gradient, which is all over the web. But the funny thing about this one is that I think the first mention about this I found on the Stripe website, and it's usually referenced as the Stripe gradient. But if you look for it, like there's a couple of other websites that are actually using the same gradient. Hello, buenos dias, mis amigas. And what? Yeah, so there are a couple of other websites. Well, actually, probably hundreds of the websites using this thing. But what's so funny about it that there is actually even the websites that kind of generate this thing. But once you export this, it is actually like if you go into the code. And by the way, this gradient is done with the mini.jl library, which is which is just a mini.jl library, mini.jl.js, just a really minimalistic JavaScript library for WebGL. And yeah, there it is. It's really small. I don't know what was the size, like 10 kilobytes, something like that. So it's just a very small, but it's last updated 6 years ago. So maybe it was just a demo for this library. Yeah, no, the demo is different here, but whatever. Anyway, so this is done with the mini.jl library. This is done with the mini.jl library as well. Now there's this thing which is like different domain, and you can generate this thing, and it is actually mini.jl as well. And you could see it's already obfuscated code. Like you could, I don't know how you can tell this is obfuscated. It's usually, I mean, this looks obfuscated, and this is taken probably from the stripe.com website, directly from the code, and then just accommodated as a separate module. But the code looks, I mean, shitty, obfuscated, not editable. So I went on looking more. There's even the website with a really nice interface where you can pick different colors for the gradient. And then it generates you like the CSS. The JavaScript just takes those values from the CSS, which is actually like a nice way of transferring something, like offsetting some variables. Although I would prefer HTML, I think it's more editable. But anyway, it's a really like peculiar way of setting WebGL vars, right? So you can just set them in the CSS for some canvas element and then take them with JavaScript from those values. Anyway, so this nice thing, this nice gradient, and it tells you to get the project from this code, and this is actually the same code. Well, at least they give the credit, so it's a stripe.com animation, and it's the same obfuscated shitty code. So this is nowhere to be found. At least I wasn't able to find the normal code. And what I also find kind of funny about it is that like Stripe, well, I'm totally about the argument of performance and the size, and using 10 kilobytes of code just to achieve this thing is perfectly fine because you save a lot of code and the code base is less to support, I guess. But then if you just scroll stripe.com, they actually have full three.js demos in here. It's three.js, just believe me, it's a full three.js. So, and usually when you develop nowadays, you don't want to use some minimalistic JavaScript library because you never know what's going to be the next request. Anyway, so I hope at this point you understand that I was just bound to build this with the three.js and decided to share and explain how actually this animation works, even though it's kind of simple, but it turns out it's one of the most popular requests by the clients. Everybody loves lava lamps, right? So this is it. We're gonna build this and also show you a couple of different ways how you can mitigate problems and how you could achieve it even cheaper than this. Anyway, we're gonna be building Stripe gradients today, lava lamp. Alrighty. So the first thing important about this is you could actually achieve things like that a lot cheaper, but then, well, they will look cheaper because this one looks pretty cool. And what's cool about this one is it's not just about the smooth colors here, but you could also see the crisp color change in here, which kind of adds this super cool look to this one. And you can see the same on the stripe. They get these crispy parts in there too. Right. So let's build this. Let's start with a hello to France, Taiwan, Argentina. Ooh, I have a couple of viewers from Argentina now. This sounds crazy to me. Hello to Zagreb too. Zagreb, Turkey, Texas, India. Oh, we've got some. Do we have 3 viewers from Argentina now? This is crazy. Actually, my intention for this year was going to Argentina, to Bariloche. But maybe once we finish this business, I'm gonna go there. All right, so I'm gonna call this one Stripe. So probably the credits go to some Stripe developer. Hope maybe someone knows who did that thing first. Anyway, let's get started. Hope you don't mind that little explanation thing I did at the start. Let's get started. Yeah. So yeah, because I have to build the website and I already used three.js there. There was no point for me to export this shitty code. And it would be like embarrassing to me even to export that obfuscated code without understanding, without having all the options. I could change Reunion Island. All right. Economy code. Well, keep getting the economy code. What's that? How many top-down arrows do I need to? Double top, double down, left, right, A, B. What's going to be the start on the web? Anyway, let's try that. That didn't work for me. Some reason, I don't know. Okay, I'll try the enter now. Didn't work for me for some reason, but I'll try that in the end. Happy breakfast to UK citizen too. All right, so where do we go? Close this, close that, open up this. So this is where we start. Also kind of want to use this opportunity because a lot of viewers are not very yet. Sometimes people just start to learn three.js and shaders, and kind of this stuff I think helps you to understand how all the shaders thing and shader animation usually work for you. All right, so this animation, what's also peculiar of him? Oh, hello to Poland too. I have to learn what's in Polish. To dobry rank. I guess should be close to Ukrainian. We are close. All right. What's peculiar about this stripe animation as well, for me at least, that it actually, I mean the original at least, it is actually done almost without help of fragment shader, which is weird because usually things like that done with the fragment shader, because I remind you the fragment shader is the thing that colors stuff on your screen, and the vertex shader is the stuff that just distorts the shape. So anyway, well, I tried to enter, but it didn't work for me for some reason. Yeah, tried that. Righty, so let's start. I will move maybe camera a little closer. Right, so we have this plane. Well, first of all, to make some distortions with this plane, usually nice to see how it looks like in terms of actual geometry. And then to distort this thing, you have to make it pretty detailed. I mean, you could make it 30, but it's usually not enough for smooth animations. And 300 by 300 is actually, how much is that? 100,000 of points in the 3D space, which is actually not that big for webgl. I mean, it's medium big. Hello to New Zealand, that's crazy, and to Germany as well. All right, so we have the full time zone puzzle combined, I guess, today, because we have New Zealand and we have Argentina and we have Europe. I guess this is the full planet, right? Okay, and we have Taiwan also, right? So we have this thing. So this animation actually consists of two animations. First, we need to distort the geometry, and then we will need to distort the actual, something else. So let's go to the vertex shader. Also, while we are starting the template, I kind of want to get the nice colors. We'll make use of this later, just to install all the things that we will need. Sure, we'll increase it right now. Yeah, so it's parcel. Hope that's better. Gonna move a little. Don't really need this. Yeah, hope that's gonna be much better. Right. What did I need a lot of screen for the code? All right. Right. Okay, I'll give it another chance. I have an English set here, so I don't know, for some reason it didn't work for me. Maybe because I'm streaming and the software somehow gets those events. Not sure. Well, I'll try that in the end of the stream. I seem to did everything right. Don't know why. Okay, so let's get started. First of all, we have the UVs. We actually have the output of the UVs already, like the green and the red. This is the coordinate system. And second, I actually need the noise function, of course. It's all built with the noise function. I think I need simplex 3D. One should be the one that I want, right? This does it take? Yeah, it takes three-dimensional thing. Collapse this. And because we have already this thing, I can introduce variant, big color, go to the fragment shader, another big color. And then instead of outputting my UVs, I can output V color, which should be just black, probably. Not even black, it's nothing because do we have some JavaScript errors already? We color undeclared identifier, but oh yeah, right. Here is correct. Correct. Now it's black because, well, I set the black color. So you use variants to go to Albania. Target today is stripe.com and all the clones of it. Of course, if stripe.com is not a clone itself. Okay, so yeah, just to check that everything is working, let's set some gray color. Yeah, it's gray now. Working good for me. Okay, now let's try to apply some noise. So just calculate noise as noise. Noise, actually like this name for the function. Let's get this noise, and we can do it with just using UV for the first two coordinates and then time for the rest of them. We already have time because in my template I have the time variable for time uniform for my shader. Now we have this, which is the same thing because I'm not changing anything. And this is probably one of the most often made mistakes with the shaders, because you do something, but then you forget to actually update the output. Well, this is actually what I wanted to do, kind of. Maybe like this. So my whole plane is actually, I only need to update the z coordinate because my plane is now looking at me, straight at me, and my camera is has an offset on the z axis. So this whole thing is looked from on the side. So I probably need to just update the y z. Oh, really? They only made it for the Mac. This is so weird. I mean, it's webgl. What's so different between Mac and Safari? I mean, Mac and Windows. Well, you never know what bug they stumbled on. So I only need to update Z, and well, there are a bunch of ways you could do this, like the usual teaching kind of style. How you show how you can update something in the vertex shader is by actually doing this kind of thing, multiplying this. No, actually, there's gotta be a small value, and nothing is happening yet. And this is what I'm talking about. You have to replace the output variable. And now you get the sign, the perfect sign. You could actually like preview, like in the MATLAB or something, all the functions you ever dreamed of previewing, like this. What's that? It's like holder for the X, right? So you can put the X there and they're going to be perfectly safe. You can also, apply any weird function. Is there a tangents function in the there was a tan function, right? Or is it the... Yeah, so we have the... But it takes 2 dimensions. Okay, too complicated. Anyway, so you can apply some distortions there, but let's apply the noise here then. So we have the noise function already in place, and we can apply noise and get the nicely distorted plane already. Maybe let's bring back the UVs. It's gonna be look cooler with the UVs. Now we have the perfect noise. Hello to Tokyo. Now we do have like the full both hemispheres, both what other parts of the world. What's that? One is a hemisphere and the other one is... Anyway, we have the full globe. All right. What else? Kind of want to explain the basic stuff here. Next, next we gotta be following the actual thing that they did here. I think it's even smaller than that. This, then I think like using the UVs for this is actually kind of an overkill. So because I mean you could see that the waves are too big to see them. So for this, usually are introduced chords, and they usually something about the UV just multiplied with something. And in this case, I don't know. I make it different values for a reason, because if you make it the same value, then mostly you're gonna get like rounded kind of things on your screen. If you make it a little asymmetric, you're gonna get more, well, asymmetric output, right? So you're gonna get more, I guess, more natural kind of thing. Maybe we can make it even the golden ratio thing or something. But yeah, nice more. I bet it kills the stream quality, so I'm gonna disable it for a moment. Yeah. Yay. All right. But yeah, actually, more is one of the ways to create art is to create it with Moir. Hope I pronounce it right. All right. So now we have the noise chord, and instead of using this, I'm gonna use the noise chord. It's starting to look kind of nice. Like already, I mean, it's already looking like that background, right? But we can do better. Trust me. There's one thing that I like about the second part. Okay, so we have the noise value, we have this thing. Quite interesting to me. Of course, we could take a different path to achieve it, like the Yawo way, but I'm kind of curious how the original effect was achieved and what was the origins of that. Like, why did they do it? So in the original animation right now, we are looking straight at the plane, which is not really cool because you don't really see all these shapes, right? So what they did in the original animation, and what is also nice about this, like right now, the shapes are only the one important thing I forgot to change about this one is that the shapes are only changing now the with the time. What you could do as well, you could change them with the like you could shift one of the coordinate as well. And this is usually the best way to use noise is not just apply time for the third variable. So when you have three values here, this is two values and this is one value. We're only changing one value. What I want here is to change two values. So which one it will be? I think it's going to be the x. 5/3. This is way too fast. Let's slower. But it kind of yes, those two values should be related to each other. Like the last time should be faster than this time. So let's make it, if this one is 3, then this one should be like 10. It just looks a little better, even though you can't really see the movement. Like if we just make this one 0, it's going to be just moving. But this movement is really slow, but if you combine those two, it just looks more natural. I mean, they are moving a little bit. They're not just up and down thing. Доброго ранку, Львів. All right, so this is how we get in there. So let's repeat the way that they did it. They also have the tilt thing. So they created the tilt, and the tilt is exactly the like 0.5 multiplied with UVY. So by tilting, we just tilt it from us. Yeah, so this value will be between 0 and 0.5. And if I just add this one here, so the noise is 0.2, then plus tilt. it's tilting the other way, so it's probably minus tilt. So we're going to tilt it from us, and you're going to see more of those things. And you can even, I don't know, make it more drastic, and you're going to see even more of those things. We obviously will need to move the plane just so it fills the whole screen, but anyway, we already have this tilting. I think this could is the same way be achieved with just mesh rotation at this point, but anyway, because they used mini-GL and probably it's complicated with mini-GL to rotate the plane, they did this. Also, what I find peculiar about this demo, in all of them, there's one part commented out, which is kind of weird to me, but it has the one part commented out. So we have tilt, but we don't. We also have the incline for the the different kind of rotation thing for the plane. So in all of those demos, if you go here, they have this value, this angle, and this angle is always 0 in every one of them, but they still have the incline there. And I was wondering why would they need them? What is that incline? So let's just show what you can also, how you can also move this whole thing here. So this incline is going to be something with the UVX, not the UVY, but UVX. And then also 0.2, I guess. Now we can add this incline and see what it does. Well, I guess we will need to make it bigger. So this incline actually kind of tilts it the other way, right? But now depending, oh, it's just gotta be the X. Yeah, so it just kind of rotates your plane in the other way. Make it 0.5 again. You could see it's not looking straight at us, and this just gives you even more rounded, kind of tilted shapes over there. Maybe, I'm not sure, maybe Stripe used that because they have this angle area, and just to achieve like more perfect design look, they also incline the whole plane just so we have this thing. Today's challenge is kind of an easy one. I'm just trying to create a more, I don't know, kind of an easy stream before the nuclear war starts. And then using my chances here. Yeah. So this is the incline, but not only they use the incline, they also use the I don't even know how to call this kind of 3D transformation. I think it was called offset in their code, and the thing is, it's also something like smaller, incline, and then they just made it between incline, it's the value, and multiply it like this way. It's going to be a value between 0 and 0.5, which is okay. I can still add the offset here as well, but it's going to be hard to see the output here. So what I could do here, kind of map the UV Y. So it's a vertical mapping now. So I map this value, which is between 0 and 1, to minus 0.5, 0.5. I might as well do this and just remove this. And this way, well, let's just move all the rest to 0 just to see what this does. This is also a designy thing, but those small things combined, they actually make it beautiful. So this is how the plane start to look like from the top. Like we just kind of distorting, it's just like a rotational distortion to the plane done, right? So when you distort it this way, all those bubbles, all those bubbly things start to look even more kind of weird, natural, lava lampy kind of thing. So this is why this thing is used. And probably, I think that was done just to achieve this kind of look that this section is really like a part of the website. So this angle structure is just like in rhyme with those shapes. Probably, this is my guess. If you know the reason, just tell me. Anyway, so this is the thing. So we're gonna bring back all the stuff like the tilt and the incline. And also, like this way, it looks too much bubbly, but you could see the waves are starting to look like weird because we are like making all those weird rotations and shapes, and this makes them look like not so boring anymore, I should say, right? It's not as boring as it used to be. The waves are interesting now. They have an angle, they kind of look like something more natural, right? Yeah, torsion. Yeah, I think this is torsion. All right. Next thing. So not only this, we can also do this noise max, and this way we just remove the like downs from our like the thing that goes negative. So all the waves are now only positive, and this makes the shapes even more interesting because we don't have the bottom lines anymore, those bottom gradients. We only have those weird shapes. I don't think this noise, well, should be that big. It just need to be kind of small, right? Now it's just all about the angle from which you're looking at this thing. This looks already kind of nice, right? The default noise, it's like the mountains from the fog already, even though we're still not using the colors. All right, but let's use the colors. This is the vertex shader kind of part. Now, how could you exaggerate torsion? In this case, well, I mean, they use just the incline part, and this is I don't really. I mean, the perfect way to do this is rotation, because I actually did this kind of thing. By the way, maybe something might be someone might be interested in this. What drops? Yeah, so I did this thing for the code drops, and that's the code, and this is exactly like the same distortion thing for 3D shapes. Sometimes you could achieve some peculiar, interesting kind of shapes with just rotation based on the y coordinate of the shape. It's not going to be UV in this case. It's going to be something different, but still kind of nice. What's the shape here? Oh, I can't click it. Anyway, plus was the best, I think, with a matcap texture. Update my browser? What do you mean update my browser? Right. So anyway, this is the same thing. It's just a simpler kind of effect without rotation. We're just adding some value depending on the like vertical coordinate of the shape, of the original shape. Anyway, so now we have this. What was that? Incline. I don't think I need big of an incline. It's kind of small. And then let's move camera closer so we are looking at the shape at all times. Right. Hello, I'm good, thank you. Next we need the colors. First I need to set the colors. That was a nice color palette thing. Didn't I just copy? And then colors. Yeah, kind of like this. And then console logs, preparing some stuff. So we have the array of 5 colors. Will Copilot help me here? No? I just want to convert them all to the actual three.js colors. Now we have three.js colors in here. Now I need to set the uniform. So I want to get all the 5 colors to my shader. This. You can set uniforms as an arrays, although you can't use arrays in the JLSL. I mean, you can set yourself an array there. You can just use them as the uniforms. And then it's going to be uniform 3, 5, because we have to set the number of items in the array. And now we have the V color thing here, right? Somewhere here, yeah. Let's set V color to... And then on the fragment shader, we're gonna set the V color. Yeah, it's gonna be random now because, well, because I'm using random. Maybe for a second, let's do this. So later on I can uncomment this. That's gonna be the same color, maybe something else. Okay, this is boring. This is poopy. Give me some nice color. Okay, this will do. It's a material theme for the Visual Studio Code. And I believe now it's an operator font. It used to be something Menlo or something like that. All right, vertex shaders. Now we have the colors. Now what I want to do, I want to use all of those colors. If you look closer to all those things, that they're using a lot of colors in here, like the purple, the blue, the red. I mean, there are, I think, at least 5 colors that they are using there. So first of all, we set kind of the basic background color with this one. And then we kind of want to apply a lot of noise functions and create a new colors here. This I will create the for function. Oh, it actually helps me to create the for function until 5, maybe for now until 1. Here I will probably use noise and I will use colors. So first of all, let's calculate noise. And because this is a scope, I believe, okay, kind of helps me with something. Oh, this seems similar to what I used here, right? So it just copy pasted the code from the previous line, which is still nice because it remembered the code from the previous line. And yeah, now we have this noise function, and I'm only iterating it once. And what I can do here, maybe let's set the last color here, and here we will be starting from the first. So V color is gonna be equal, well, yeah. So we're gonna just mix V color, which is gonna be something like aggregating all the previous colors with a new color and with the noise. And let's see what's gonna happen. It already looks kind of nice, but it's not 100% like how it did, because we can do it 5 times, right? Wonder what's gonna happen. Nothing interesting, because we are calculating the same noise every time, and the same noise is put on the same spot, so it just overwrites all the colors, and in the end we see only the final color, or probably something like that. You don't really see all the 5 colors here. By the way, this is an interesting question about extension to use this thing, because the funny thing, I don't even know. It just appeared at some point, so it was some extension that updated, probably. And how you see the extensions here, the installed ones. So this is probably either GLSL lint, which is what, outdated or something, or webgl GLSL editor, maybe one of those. think it's gotta be this one. This is deprecated. Oh, maybe it's this one. No. I think it's one of these ones. But I don't know which one. It's either shader language or JLSLX or Clang. One of those. I have all of them. At some point it just appeared. I guess they updated the extension. And I'm not yet sure if I love it or hate it, because sometimes it's just harder to read all the stuff in here. Although it helps, it might be actually helpful for the beginners, because it will show you where do you actually have the variables. Although for some reason it doesn't show it here. Like here I also have the vector3 and a lot of parts of vector3, but for some reason it doesn't show it here, but it shows here. I don't know. Yeah, exactly. And this is exactly what we're going to do now. So not only we can use a different time value, like I think in the original it was called something like noise flow, which is like we have two actually two velocities for our noise. One velocity is for moving noise, and the other one is just for like working out noise. And we can now create all those variables. So first of all, I think noise flow was what was that? I think it was kind of big, should be the big value. And here, not only that, it's a bit more complicated, but this is the final step. So we have, I like it to format like this sometimes, because you could easily see all the variables now. And when you do this, it actually kind of looks nice, right? It says where the V0, V1, and V2. Okay. So there's a noise flow, which is going to be this one. And let's not make it the same. Let's make it I multiplied by, I don't know. It shouldn't be like really different. It just gotta be slightly different, so they're moving out of place of each other. And also we can do this. I think noise flow we have here, and here we can do this because this is an integer and this is the float number, but let's get there. Noise speed as well. So on each iteration, we're going to change the values for the noise function, and this way we will just move all the things out of, move them not on top of each other, but into the different places. Right, and the noise speed, this one gotta be faster than the noise flow, right? Here we had the noise speed like 10, and this gotta be 3, so let's make it at least twice bigger. Of course, you probably could play with those values. Now, well, just to see the actual error happening, because yeah, this is the integer and the float. To mitigate this problem, just convert this to float. We're gonna be fine. We are still kind of, we got more colors, and with time we're gonna get more of them, but we have also the noise seed, so we can just add some random big value here, which is like the place where the noise will start, which is gonna be, I don't know, 1 plus, I think any value will do this, any big enough value. And now the noise starts already with the kind of already separated from each other. But we can do even better. I think sometimes the noise is too, because the gradient is too big of a gradient right now. I mean, we have those values, these noise. It probably gets negative as well. So I think I gotta multiply it with 0.5 and add 0.5. Or was it? Now it's too much green. Seems like too much green now. Maybe it's not negative. Maybe it's not going negative after all. Let's see a couple of other noise functions. I mean, color palettes. Yeah, seems good enough. But we can improve this. Yeah, like plasma or lava lamp. These are all the keywords you want to use to Google such effects. This is also achievable with the CSS gradients, not performant at all. And with the SVG filters, horrible performance as well. So this is only basically achievable with the webgl because of performance. Okay, so now you just gotta play a little bit with the values. So at this point, it's already the effect. I mean, maybe we could make a little bigger. We could also change the noise chords, by the way, which is gonna be what? Noise flow. This is what it proposes to do, but I'm not sure it's a good idea. I think so we have the noise chord X, so we just multiply the previous noise chord basically with the new noise chord, right? So this way, maybe just call it frequency. Because right now the spots of the are too big, are too small. I mean, too small. If we multiply it, it should be better. So 3 or 4, something like that. Make them 3 or 4 smaller. Noise frequency. (167) dimension mismatch. What was that? So noise frequency. Okay, 4. And then another one. Okay, maybe I gotta make them smaller instead. Well, now it's 2 lava lampi, but it actually, you could see it already. Already could see the effect. Maybe noise a little bit bigger. And this is kind of the effect that we are seeing in there, right? Except now we have it with the hello to Pakistan as well. Except now we have it full screen with three.js. So what else could I do here? I think the noise frequency is fine. What we could also do here is yeah, just make them. I thought that I make them bigger, but I made them smaller actually with these values. What else could I change here with the index? Maybe I don't need the last color because I'm already using the last color in there. Nice, cool. I think it's gotta be even slower than that. Kind of like this. And the camera could be moved even closer. Or the plane could be made bigger. And or the inclination may be too big an inclination. Maybe I could just actually increase the size of the plane at this point. So it fills the whole screen. Yeah. Well, this one, I actually like this color combo. This one looks pretty cool. This is already it. But I think they even went further. So this effect is really a lot of layers. I believe the developer tried a lot of things to improve it, to make it even cooler than that. And one of the ways that they tried is actually not using directly this noise, but using it with the noise floor. So at this point, it's already like that effect, but maybe this one even makes it better. So they use two values, like the upper and the down value, top and bottom value, and noise top was, should it be the seal from the top, like the ceiling, and this one was dependent on the index. What was the value? Something really small, so it shouldn't go over the 1. And because we have 4, so it should be nice. So here, instead of just using the noise for the noise, we could use smooth step and smooth step noise a little bit. And here noise floor, noise seal, and then another here. Right. Is this it? Format it a little bit. I don't really like it here, like it's just redundant. Why would I need this value here? It would look nicer without this value comment, but still kind of cool. And now, like, all those colors are nice. This is why it's called nice color palettes, obviously. But what else? What else? Already thin, right? Just the speed, just about the speed and the settings, depending on the the vibe that you want to achieve on your website. So these are all the small things that you could use. I mean, it's not, I'm not just replicating them for the sake of replicating them, but maybe I do that. But it's just to, so you can see what the small things you could apply to the values to make them more natural, more beautiful looking. And this is one of those things. And just to play with it a little, like this way, we would just get the kind of the blanket patches, like patch blanket, how do you call it, right? You can even make it smaller. But it's plus here. It's like this, and because we are using this, I will remind you, we're just using this in the vertex shader. That means we have a lot less computations going on, because the fragment shader gets computed on every pixel of my plane, and the vertex shader only on each vertex of my plane, which is just, I will remind you, roughly 100,000. And what's also nice about vertex kind of animation, vertex colors animation, is that, well, let's bring back the seal here. So it's nice again. But what's nice about this animation is that instead of 300 by 300, if I just use 100 by 100 at this point, no one will actually notice. And this is like a lot less computations, like 10 times less computation in shader, this than 300 by 300, roughly 10. And well, the look is still the same. I mean, yeah, you can see some glitches right here, right? Where the value is changing. And because it's a vertex shader animation, it only interpolates on the vertices, just to exaggerate this. Yeah, you could see a lot more like angly kind of stuff going on. This is what happens when you animate colors in the vertices, not in the fragment shader. But with enough points in 3D space, you could just get away with it. No one will actually notice that it's just that, and you get a lot less computation going on the computer, right? So it's way more performant than the same effect that we could have achieved here. And well, here we actually run in noise like 1 time for the vertex animation and 4 times for the color animation, but it's still far more less than we would have here. Because here, at least on my retina display, it's roughly 1000 by 1000, which is already a million, which is already a lot more than we have here. We just have here 10,000 multiplied with 5, like 50,000 computations of noise on each frame in the vertex shader. And here we would have a lot of noise values, but a lot of noise computations on the fragment shader, a lot more of them. right? So hope you get the point. And when you actually this thing looks the best when you have the close colors like this, right? It's just I can't get enough of this thing. All right. So what else could you do here? What else could you do here? Well, obviously you could play with all those values. Like maybe let's finally use like more color patches here, more detailed colors. This looks awful. This looks actually better. So sometimes you want more colors presented on the screen, and you could already see, maybe, I hope you could see like the bugs here, like the bending happening here. Sometimes you could mitigate that bending with just with a noise. So you could just put a noise over the plane and you could get the bending get away. But in this case, I think we just, if the performance budget allows us, we could just increase the number. Oh, I like this. This is one of my favorite color palettes. I like this one. Should remember its number actually. Keep reminding myself to remember that number. Was it somewhere? Which one of these it is? Somewhere here. Oh, maybe it is this one. Probably, yeah. So it's somewhere closer to the end. So it's a big number. Because they have 100, exactly 100 color palettes here. And you can randomly get one of those. Alrighty, so I think like I'm gonna make it smaller, like multiply it with something like this. And it's gonna be nicer. And we got this. Thanks for being with me. Hope you liked it. I'm gonna read the, yeah, that's operator mono or book, maybe one of those. I still yet have to try Mona Lisa, maybe. But it looks, in a lot of ways, it looks actually similar to. They don't really compare it to operator here. In terms of fonts, I would also advise you like to try nerd fonts. They are mostly used to achieve some funky looking command line thing, but they also have a lot of characters that you don't really have in the usual fonts, and sometimes it could look some ligatures that could look really nice when applied to the code. So this is what I would recommend you to try. Yeah, it is awesome and performance is good, and of course mini-gel version will weight a lot less than the three.js version, but who are we kidding? We are usually, if we want to apply some webgl effect, client would not stop with just this. Then he'll want some, I don't know, particles flying around and some 3D model loaded from the GLB file. You never know what's next. You never know what's next. I think in the previous streams it was Menlo, but I switched to operator again. I used to love operator because they have italics. Like you could see the italic font for some of the keywords here, which I kind of liked. But honestly, I think it's just about the change. It's like you used to sleep on the left side of the bed, now you sleep on the right side of the bed, and then in a year you just switch back. And this is the story for me with the fonts. So I just switch back, and then maybe in half a year I switch to something fresh, which is gonna be more delightful. So I hope you like this stream, guys. I tried to explain it a lot, so it could be used as a maybe beginner kind of stream, because all we do here is just running noise and comparing some values with each other, which is probably all you do in JLSL usually. But anyway, it's kind of a simple one. We only worked with the vertex shader here, which is nice for performance reasons. And I just showed you how you can use a random lava lamp kind of thing, and easy. And this is exactly how all those effects are built. Maybe just the values are a little bit different. Also liked this effect in Miyagami, because you could also mouse over here and have a slight zoom. So all of those are actually different WebGL canvases. Yeah, not just the colors. I usually just log the index. This is what I do. But this is what I do when I do the generative art kind of coding. So I do this, right? So then I can like come back to this thing. I actually used the same color palette to my latest. I can show it, right? I was a little bit, I don't know, ashamed maybe to post this. Not good enough kind of thing to post this on the web. But I think I achieved some nice result. So I experimented with the yeah, with the how do you call it? This is the same color palette, by the way. You just used in the generative art here. So I experimented with the. It's not just the. You could see a lot of different things, right? This is why I love generative art. So I experimented with the machine learning and normal maps, and then so this is built with the 2D actually, but I create normal map based on the machine learning. Kind of a nice, super technical kind of thing, but looks good enough for the postcard, right? But these are all the same palettes, and I do save them sometimes because some of them I just like. Like I like this one, and I also like well, this one and this one I like. Yeah, I mean those saved are all the one that I like. Buenos dias to Mexico. And yeah, this is what I do to keep me cheered. Oh, I'm glad this is the best compliment. 4 a.m. This is crazy, man or woman. I don't know, but this is crazy. Like I'm happy that someone finds this valuable in the 4 a.m. Thank you everybody for being with me. Guess I'm gonna go and try to eat some eclairs. And I hope you had a great time being with me and learned something. I'm gonna share the code on the Patreon. And otherwise, have a nice week. Say some good and kind words to the people that you love. Don't forget to do that. With the like nuclear threats, it's actually feels better to say those words to people more often. Sometimes you just hold it back, like, okay, it's not the time, but now it's literally in Ukraine. It's like, you never know. You never know, so you should do all the things that you want to do today, or maybe tomorrow, not postpone them. Thank you everybody for being with me. Hello to all the countries in the world. I'm flattered with you watching me. Hope you like that. I'm gonna try to stream more often. I'm gonna create more often videos, post more often. 6 a.m. This is crazy. This is crazy. Have a nice day, everybody. See you in Twitter, in chat, in comments. And comment and like, by the way, comment and like the video. Helps a lot. Maybe I will get more views and will be a super popular YouTuber.